Hello, everyone. Good morning, good evening, good afternoon from everywhere you are. I'm so happy to be here with another great session with Microsoft Zero to Hero. Before we start the session, let me share some slides about the community. Today we have Stefano. He wants to talk about the Azure Logic app. The topic is very interesting, and actually let me share some information about the Microsoft Learn community. As you know, we are part of Microsoft Learn community. Microsoft Learn community is a hub about a lot of content for learning. You can connect with Learn expert. You can ask your question. You can find your certificate or learning path based off your role, based off the certificate. And actually, this is our October calendar. We have a lot of session, and this session is the first of our October session. All previous session hosted on our YouTube channel. If you don't register for future session, please register for interesting topic. Interesting. We have every Saturday session from Microsoft Zero to Hero. The last slide is our code of conduct. Be aware of other, be friendly and passionate, be welcoming and respectful, be open to all question and viewpoint, be understanding of difference, be kind and considerate to other in the chat, in the question. And now it's time to add Stefano in the stage. Hello, Stefano.
Hi, everyone, and thank you, everyone, to be here. I will start sharing my screen, if possible. Okay, perfect.
Just sorry, Stefano, interrupt you. Just for your information and other participants, all of the guys can ask your question in the chat. End of the session, Stefano will answer your question. And actually, we can select a best question as a winner for Microsoft Exam Voucher discount for fundamental and advanced Microsoft exam. Stefano, the stage is yours. You can start your presentation.
Okay. Again, thank you, everyone, to be here. The session for today is about Azure Logic Apps, but not about the Azure Logic Apps platform in general, but we will put the focus on creating high-performance low-code workflows, and especially with new features in the Azure Logic Apps platform called .NET Code Injections. Before starting, some words about me who don't know me. I'm a Microsoft MVP working on mainly on Azure and the business application, and also I'm the Microsoft MCT regional lead for Italy. Here are my contact. So in any case you want to reach me for any type of question you have after this session, feel free to write me on one of these channels. Before starting about the core of the topic for today, let me spend some words about what are low-code workflows and why low-code workflows are important nowadays in creating cloud-based solutions. Low-code workflows, in generally speaking, are a nice way to create and automate business process and business tasks using a low-code platform. So you don't need to write low-level code, but simply you need to orchestrate your workflows using built-in connectors, built-in actions, and low-code workflows are extremely important nowadays because they can help you automate business process faster and easier. You don't need to write code, too much coding skills. You can reduce cost due to that fact, and also save resources because you can reuse your workflows across different types of problems to solve different types of problems. Local workflows also improves the collaboration when orchestrating a complex workflow because it's easy to understand a low-code workflows compared to, for example, Azure Function, where you can see tons of codes. In low-code workflows, you can see all the orchestration of the actions in a graphical way, local way, and also a consultant or something like that can understand your core workflow and collaborate on improving that. And the low-code workflow also helps you on adapting to business requirement and change of the business requirement, because you can simply start from your existing workflow. Is a business requirement change, you can go into your designer and change the orchestration or your workflows easily. So our low code is probably one of the hottest word in the last years, and low code workflows are extremely important for that. But when I often talk about low code workflows and why they are important, but when talking about that, I always emphasize a sentence. So low code sometimes is different than pro code. So this means that what I mean under this sentence, writing a low code workflow sometimes is easy. You can just use the right connectors, just use the right rules, and orchestrate the right actions in the right way, and the workflow probably works. But a workflow that probably works doesn't mean that this workflow is extremely performant, or doesn't mean that is the best way to solve a problem. Sometimes mixing low code and what I call pro code, so full coding into a workflows, helps you on creating a very performant solution. And that's what we want to talk about today. For introducing that, let me spend some words about the Azure Logic Apps models. The Azure Logic Apps platform has, at the moment, two main deployment models. The first, and probably the oldest and the most common deployment model, is what is called the consumption model. The consumption model, as the word consumption say, is a pay-as-you-go model. So this means that you can orchestrate a workflow in a local way. This workflow runs in what is called a multi-tenant environment. So in a set of resources shared across workflows, or inside what is called a dedicated service environment. This means that you can have a set of resources that you can acquire, and your workflow runs inside this set. When you create a low-code workflows in a multi-tenant environment, this means that the workflows and resources are shared across customers. So this means that probably performance of the workflows cannot be maximized simply because resources are shared. In the consumption model, a low-code workflows can be only one. So a single Logic Apps instance can have only one workflow. You cannot have more than one workflow inside the same Azure Logic Apps instance. And in a consumption model, in the consumption model, you have all the triggers, all the run histories, or your workflows and something like that at the Logic App level. So you can monitor fully your Logic Apps at the app level, because it's one-to-one Logic Apps and Logic Apps instance and workflows. Logic Apps then has evolved during the time, and the evolution of the Azure Logic Apps platform is the new deployment model called Logic App Standard. Logic App Standard is a new Logic App, a new deployment model that runs in what is called a single tenant. Single tenant means that there's no shared resources between different customers or different Logic Apps instances. So you decide to have an hosting plan with a selected pricing tier, and inside that hosting plans, your Logic Apps workflows runs. Logic App Standard has a new technology under the hood that is called the portable runtime. And the portable runtime is a runtime for Azure Logic Apps that literally runs anywhere. Runs anywhere means that it's under the hood based on the Azure Function Runtime. So you can host your Azure Logic Apps workflows inside Azure, or also inside other cloud providers, inside containers, Docker containers, for example, and also on-premise, things that are not available absolutely in the consumption model. When using Logic App Standard, you create a single Logic App, so a single Logic App instance, and this single Logic App instance can have multiple stateful or stateless workflows. So two types of workflows, stateful and stateless. We will talk about that later. And you can have more than one inside the same Logic App instance. So you create an instance, and inside that, you have multiple workflows running on that instance. All workflows share, or inside the same instance, Logic App instance shares the same processing. So compute, memory, storage, and so on. And at the moment, you can select some of types of set of resources. Here I've put in evidence the more common. So VS1, VS2, VS3 that have a different set of virtual CPU and memory available. When I always talk about that, I always emphasize that don't do a comparison between these and a machine, a local machine like a personal computer or something like that. These are totally different things. So for example, VS2 instance, you can run every type of production workflow you have today. I'm absolutely sure about that. But you have also the VS3 instance that has for very, very large and complex workflows, but VS1 or VS2 are absolutely enough to run every workflow that you probably have today. Logic App Standard, as the Logic Apps consumption, relies on connectors. But Logic App Standard has a different behavior when talking about connectors. Connectors usually in Azure Logic Apps are managed by as Azure resources. So when your workflows you instantiate the connector, there's a connection with Azure that downloads the definition of the connector. With Azure Logic App Standard, you have some connectors are what is called built-in connectors. This means that they are inside the same process that runs your workflow. So when you instantiate one of the built-in connectors, for example, for Azure Storage or something like that, these are built-in connectors. You don't have to, the Azure Logic Apps runtime doesn't need to connect to Azure in order to download the definition, but all is inside the Logic Apps core, and this means efficiency, performances. As said before, when talking about Logic Apps Standard, so the new model, we have two types of workflows that we can create: stateful workflows and stateless workflows. Stateful workflows are means that these are workflows that preserve the state. So stateful workflows are useful when you need to keep data from the previous event persisted on storage. When you create a stateful workflow, you put in a different types of a different set of actions inside these workflows. Every actions save and transfer all the inputs and outputs of the action in a storage, in storage account. And this is an Azure based on Azure storage accounts and Azure queues. And this permits you to save the state between actions, also restart the workflow if an action phase from this action, and having the entire history of the workflows saved, so preserved. The other type of workflow are stateless workflows. Stateless workflows are instead useful workflows when you don't need to have the entire persistency of actions into the storage. So when you have this stateless workflow runs entire in memory. So they save the states of each action, input and output of each actions in memory. So not on storage. And in stateless workflows, you have obviously some limitations. Some limitations are that a workflow can run only for a shorter time compared to a stateful workflows. At the moment is the timeout for a stateless workflow is around 5 minutes. And if you have an actions of a stateless workflow that fails, you cannot restart the workflow from that action, simply because, as said before, the state of actions is saved in memory. So you cannot preserve the state. But stateless workflows are, another difference is stateless workflow can only run synchronously, while stateful can be runs asynchronously by default. This seems limitations, but stateless workflows are extremely fast. And this is why sometimes are extremely useful to be used. Another difference is between stateful and stateless is when to use that. So in Logic Apps, the first version of Logic Apps, so Logic Apps consumption, what here is called Logic Apps V1, or Power Automate, all workflows are stateful. So each action, trigger, and step of the workflow saves the history and the input and output of the action in storage. In Logic Apps version 2, workflows can also be stateless, as I said before. So you can have workflows running entirely in memory. And when you have, so you can have a set of workflows that sometimes in different scenarios, you can mix the usage of stateful and stateless workflows. For example, if you have two systems that needs to interact, sometimes, for example, system A needs to read data from system B. Sometimes a stateless workflow could be helpful because it's very quick to do the action compared to a stateful, because you have no storage persistency. Why? Or, for example, if you need to post data probably you want maybe to store in storage the data that the system A passes to system B in order to probably retry the action if something is failed. So a stateful workflow in this case could be probably the best choice to adopt. It depends on the scenarios, but stateless are extremely powerful. To show that, I've done a simple example. So imagine to have a workflow that starts from a system where I receive an HTTP request from the system, and then I need to calculate the total of some records. And this records comes from another system. For example, here I use the database connector. So our records that are stored in a database table. These workflows can be simply receive an HTTP request, initialize a variable called total, retrieves the records from database, and then for each record calculates the total, summing the quantity of each sales line in database, and then gives the response. This workflow can be created as is, with the same action, with the same structure, as a stateful workflows and as a stateless workflow. So as a workflow that runs persisted in storage, or as a workflow that runs entirely in memory. And this is the difference in execution. So if I execute these workflows, and I will show you in a demo quickly in a moment, you will see that the stateless workflow is very quick compared to the same workflows executed in the stateful way. So this means that sometimes it's better if you want performances and if you are sure that the operations runs under the 5 minutes time limit, having a stateless workflow is one of the best choice. To show that quickly, here I'm previously created a Logic Apps, and in my Logic Apps, as you can see, it's a standard Logic Apps, so running in the standard tier. And when you create a Logic Apps standard, as said before, you can create multiple workflows. So here you have a workflows tab. Let me zoom a bit. Sorry, 1 second. Okay. You have a workflow tab And inside the workflow tab, you have all the workflows running inside this Logic Apps instance. So you can have multiple workflows that can be stateful or stateless workflows. It depends what you want to do. And from here, you can create your, if I click on add, you can create your stateful or stateless workflows. Now I don't do that. To show that, I've simply created two workflows that does the same. One is a stateful workflow and one is stateless. And if I open one of these just to show what this workflow is doing, you can open the designer. And when opening the designer, you have a graphical designer where you can design your workflows. This is exactly the workflows that I previously created. So it receives an HTTP request from an external application. It goes on my Dataverse environment, loops to the customer table, and for each record in the Dataverse environment, calculates the total, summing the balance due field of the customer, and then gives me the response. This workflow is a stateful workflow, so it's a workflow created in the stateful model. So this means that every action is persisting in storage, and the other version of the workflow is the same. Sorry, I click here, and the other is the same, but is the stateless version. So this is exactly the same workflow, but in this case, it's stateless. And if I click the designer, it's absolutely the same. So it goes on, request goes on Dataverse and calculates the sum. If I try to execute this workflow, so now here I have the URL of the two workflows. One is stateful and one is stateless. And now I execute the two workflows. So the first call executes the stateful workflows. So it takes a bit of time. And then it should be, I should have a response from the workflow. Hoping that the connection is working. What I want to show in this demo, okay, now this is the time to have the calculation of the rows in Dataverse. If I execute the same stateless, you can see that the time is absolutely, to have the same result, the time is absolutely faster. I can retry because probably the first is executed. So I retry, okay, now I have about 4 or 5 seconds, but this is under 1 second. So it's what I want to show is absolutely faster than the stateful. The difference is also this. So if I go into my stateless workflows and I go click on audio overview here. In the stateless, I don't have the history because, as said before, the stateless runs entirely in memory. So I don't have the histories. Why? If I instead I go back, like select my Logic Apps, and I open my workflows, and I select the stateful version. In the stateful version, I have the history because the stateful, as said before, uses the storage to persist every action. So I have the history, I can see the logs. So the stateful is this. And if I go into the overview, I have the history. So this is my execution. I can click, I can see the entire execution of the actions. I can see for each action, I can see the input and output, and so on. So this is not available, obviously, in stateless because it runs in memory. But this is a new possibility to create high-performance workflows, because sometimes it's not needed to, you are not forced to have a stateful. Sometimes it's better to have a stateless, or a mix of the two. A workflow that calls, for example, a child workflows in the stateless way, because it's absolutely faster to do that. So this is one of the improvements in order to have, in the Logic Apps platform, in order to have high-performance workflows. And now I want to show another great and new, very new features in the Azure Logic Apps platform. To show that, I've decided to use a real-world scenario that was deployed in a customer project. So requirements from the customer project was that we have different systems that passes data. These data are in JSON format, and this data comes from different systems. So a system that saves the data into the blob storage, that some systems has data into Azure in SQL Server, some system has data as Oracle as database. This passes some data, mainly sales order data, passes some data as JSON, and we need to take this JSON data and do a merging between these in order to decide what are the orders that can be approved. So this was the idea of these scenarios. So we have to perform a complex merge of this JSON data in order to decide what records must be created into an ERP system. The workflow was started by using Azure Logic Apps. So this was the workflow as designed as in the first version. So here, I don't know if you can see in a good way in the slides, but what happens here, the workflow starts by creating some variables, and then this workflow parses the JSON coming from the systems. So here you have a parse JSON action that in Logic Apps is an action that parses a JSON given when you provide the schema of the JSON. Then we have another action that parses the second JSON coming from the second system. And now we need to match. So the matching algorithm is that for each record in the first JSON, I need to match this record with the other records coming from the second JSON. And to do that, in Logic Apps, we have a set of loops. So we have a set of for each actions that for each lines in this JSON, we need to match every lines with the lines coming from this. And if the condition is met, the order is rejected, otherwise the order is accepted. And for each rejected order or accepted order, not order, sorry, but invoice in this case, we append the accepted invoice record to a new JSON, otherwise to another JSON called rejected invoice. And then for each accepted, we need to create the accepted invoice in the ERP, otherwise the rejected. So this is the workflow as created in the first version. This works. So customer was happy. The workflow is created, totally low code, easy to understand, also for a consultant, and the customer was happy in the first iteration. But where this workflow is low, this workflow is low essentially in two components. The first is the parse JSON. So the parse JSON is an easy action in Azure Logic Apps, but is an action that is usually time-consuming, especially if the JSON is big or if you have a lot of JSONs. So this is the action that sometimes takes time. But the really slow part is this. So all the routines that needs to do the matching, because for each line of the first JSON, and these are very, very big JSON, not small files, but very big JSON, we need to loop. So for each, and then for other, in the other lines for each. So a set of for each that are extremely slow to be executed. And we have a measure of this. So to process one data file and to merge with another data file, we measure the workflows using the different platforms. Because during this project, we have done first iteration, for the first real iteration, not considering this session, but the first real iteration was started with Power Automate. So we created this workflow with Power Automate, and this was the measure for to process a file. So about from 3 minutes to 4 minutes, it depends on the content of the file, but this is about the time to process a file. Then the workflow was moved to Logic Apps consumption. The Logic Apps consumption is the orange line here. Logic Apps consumption was a bit better compared to Power Automate, more stable. Power Automate sometimes has small instability due to Dataverse, but it's quite comparable. So Power Automate and Logic Apps consumption is quite comparable. Then we moved the workflows to Logic Apps Standard. And Logic Apps Standard was a bit better. So simply the same workflows in Logic Apps Standard was a bit better, simply because Logic Apps Standard is more stable, is more powerful. So it's the green line. But we have not so much gain. So what was the problem in this real world project? The customer started with a small set of files to process. So about some hundreds of files. And 3 minutes for file for 100 of files is about 4 or 5 hours. And in 4 or 5 hours, all the data processing was completed. The customer asked us to improve the workflows, and in Logic Apps Standard, we was able to reduce of some hours. So from 4 hours, 4 or 5 hours to 3 or 4 hours. But the real big problem was when the business of the customer extremely increased. So from some hundreds of files, we need to process some thousands of files. And with some thousands of files, the workflow started running 2 minutes plus multiplied per thousands of files means lots and lots of hours, more than 10 hours. And this was not acceptable by the customer because it gives you a lot of problems. 10 hours, 11 hours to process all this big amount of data files coming from the external system was a situation that was not acceptable. So we need to rethink something about this process. And what you need to know in Azure Logic Apps, that generally speaking, low-code workflows, just remember that there's a storage under the hood always. So when you have a nested for each or for each loop or something like that, it always don't give you the best performance because the scope of every iteration is persistent in storage. So on every loop, it needs to go into the Azure storage and save some data. So this is why the for each loop is slow by design, especially, and this slowness is probably acceptable if you have small files. But when your workflow starts becoming a real big workflow, it can be a problem. For each also, when you have variable assignments in for each, could also lead into concurrency issues because you have multiple parallel threads that try to update the variable in the storage at the same time, and so you can have some concurrency problem when you have a lot of data. And In stateful, always also the results are of the iterations and the elaborations are saved in storage on every iteration. This is why the stateful gives you the possibility to start from the failed action. It's a new feature available in Logic Apps. And so you have a big cost of latency. How you can improve that? Mainly in some ways. The first way is sometimes detach a part of workflows and batch that to another Logic Apps. This can increase performance, but this was not our case. We tried that, but this was not our case. Another possibility to improve the workflow is what I said before. So use the stateless, demand some part in stateless workflows. So run workflows that runs in memory. This can help you improve performance, but stateless have the limitation, as said before, of the 5 minutes runs. And this was not for us moving to the stateless workflow, the part that's processing the data file sometimes causes failures because data files, as you can see in the table, was processed between 3 minutes, smallest, to more than 5 minutes, the biggest. So our workflow sometimes failed. This improves performances, but was not resilient because when the data file was big, also running in memory takes more than 5 minutes and the workflow fails. So Logic Apps was out when a very new possibility, that is the possibility to run inside the Logic Apps a mix of code and low code. And when using this feature that I will show, this was the result. So in this feature, we was able to move the processing of a data file from more than 3 minutes, 4 minutes, to some seconds. And this was the result. So our entire process to that customer moves from running in 10 hours to running in 2 hours, 1 hour, simply by using this new Logic Apps feature. And this new Logic Apps feature is this was redesigned like this. And as you can see here, this is exactly the same workflow as before, but now we have this new action called a local function in this Logic App. And this was the winner because this is the action that makes the difference, that made the difference in this case. What this action means, I can show you by showing you an example. So let me open Visual Studio Code. And from here, we can, the requisition to requirements to use this function is to have this extension installed. So Azure Logic Apps standard must be installed in your Visual Studio Code. And if you have this installed, Visual Studio Code need to load. I can create this tab appears, and I can create a new Logic Apps from here. So let me close these messages that I don't want to update. I can create a new Logic Apps workspace from here. Let me save it into my document Azure demo folder. I call it Azure Hero, something like that. And you can select a standard Logic App, so as usual, or a Logic App with custom code. And I select a Logic App with custom code now. What custom target framework you want? You can select or .NET Framework or .NET Core, so in this case .NET 8. Let me select .NET 8. And I can select my function, Azure Hero function name, sorry. Azure Hero function, namespace. And what type of workflow do you want to create, stateful or stateless? let me select statefully that it's absolutely the same name of the workflow as error workflow. And I open it in a current window. A project is created now. And in this project created, this project is a particular project now. Let me close this. This project has two main building blocks. One is the Logic App project, and the Logic App folder here contains the definition of your workflows as a set of JSON file that contains the definition of your workflows. Later, I will explain that. And this is your workflow definition. This is the workflow definition. And the other sub-block is the function. In the function that you can use to create your function that you want to use in your code. So here I will show you the standard skeleton. So the standard skeleton, what is doing? It's just like an Azure function. So here is create a function that this function wants two parameters, a zip code and the temperature, and does calculation and provides the temperature of this zip code. As you can see, the function is receives two parameters from input as workflow action trigger, and returns a complex parameter, so a JSON. In this case, is a class called weather that contains these parameters. Here is where you can put your function you want and your piece of code you want. Now, I use the standard skeleton just to be quick. What you can do here, I can open a terminal in the function window, and I can compile. So I can .NET build function, my solution. I can recompile the solution. And the compiler starts compiling. And when the compiler finishes compiling my my function, if you don't have errors, this creates a library folder with containing a JSON of the function, and then inside the .NET 8 folder, you have your DLL containing your custom code compiled. As you can see here, all is packaged under the Azure Logic Apps. So all your code is embedded into a set of DLLs, one per function, containing all your routines, your logic, your business logic, your custom code. And now that I have this, I can go into my workflows. Where is my workflows? Here. Into my workflow, I can right-click this, and I can click Open Designer. And now I have the designer of my workflows, where this workflow has this action called call a function in this logic app that, as you can see here, is called with this name, and as my parameters defining my C# code, so the zip code and the temperature. And I can use it in my workflows, so I can add new actions here, provided all the actions that I want. This is what I showed before. In-app connectors are all connectors that runs inside the Logic Apps runtime. So no need to go into Azure. So here, these are all the in-app connector. Oh, sorry. I close. These are, you can select from all in-app connector or custom or something like that. So you have all the connectors available in Azure or not. So all the connectors that you have the same designer that you have online. But the power of that is that now I have an action that I can reuse inside my workflows that contains a custom code. And if I let me close this a bit, and let me open these workflows. moving on this. This is my workflows, as I said in the slides before. So this is the workflow that I deployed to the customer. And this workflow is the same as before. So what this workflow is doing is reading some blob, data files from blob storage, data coming from the first external system, data coming from the second external system. Now I need to match the logic. And if I go a bit, 1 second here, this is the first version of the workflows, as I explained in the slides. So if I open my first version of the workflow, the first version of the workflow does that. So reads the data from the first blob, the data from the second, and then initialize some variable, something like that, and then does the parsing of the JSON of the first blob, parsing the JSON of the second, so using the parse JSON action with the JSON schema, then starts the I close this. Then starts the large set of loops that I've previously explained. So here starts the set of loops. So for each invoice, in the first line, for each line, the second, I need to match in for each line the second, set the condition and discover if the invoice must be rejected or not. So this is the main goal. All this set of loops takes time, takes storage. And if I run this, let me try to run this. If I run this, you will see that this workflows takes time. So here it's very quick. But now the looping is slow because it needs to process some thousands of data files, some thousand of lines in the first data file with other thousand of lines on the other. So it takes time. Now I leave it running as is, but I don't remember if I have an history here. But you can see that, for example, last run was about 3 minutes, something like that. Then I've deployed the same workflow as from Visual Studio Code. So the same workflow that I previously explained here, I've deployed on Azure. So here I have another called data parsing learning in standard. And if I open my workflows here, this is the same workflow as I deployed from Visual Studio. So I directly deploy it from Visual Studio Code. And as you can see, this workflow is the same. So reads the same files from the blob storage, but now calls a function in this logic app. And what this function is doing, here I have created a function called the data parser that simply does what I want. So simply this function retrieves receiving inputs, the content of the 2 blob files as string. So these are 2 JSON content. And here I'm using standard .NET tools, like, for example, Newtonsoft JSON for deserializing the JSON. So very quick. And I'm doing the loops, the set of loops inside this piece of code. And this is extremely faster using Newtonsoft JSON or .NET JSON serializer or something like that, and looping in memory in order to match the lines is extremely faster compared to do the looping in Logic Apps. So here I have simply put this logic into a piece of C# code that receives 2 strings, does the line matching, populates 2 lists of strings called accepted invoice and a rejected invoice, and this gives me as output a JSON containing the list of accepted and the list of rejected. What I want to do, simply that. Deploying this on Azure gives me this workflow. and that one does the same. So the looping now is handled in this function, and then I have the same. So for each accepted invoice I create, for each reject I create, and then I save the data into my ERP system. If I execute these workflows on the same data file, so let me open this and run. So I run. This is the difference. So let me refresh. So now it runs on the data file that I have now stored are a bit more than 4 seconds for a single data file. So matching 2 data files. While in the other, I don't know if it's finished, but in the other version, I think it's about some minutes. No, yes, it's finished. It's 3 minutes. So we are 4 seconds compared to 3 minutes, simply because Logic Apps, when you have large looping, large complex JSON, and large looping, takes time. And this is, in my opinion, a killer feature of the new Azure Logic Apps platform, because it permits you to create in a single workflow a piece of logic that you can turn up with low code, with low-level code, not low code, sorry, with low-level code, so also C# code. And you can use any .NET library you want, any logic you want. All is embedded into the Azure Logic Apps runtime. So all here, as I show, is embedded into your Azure Logic Apps runtime. So here I have all the DLLs that I've used in my. These are when you deploy this workflow on Azure, these workflows and the connected DLL. So my custom DLL is data parser DLL in this case. These are deployed into the Azure Logic App instance. Someone can say that why not doing the same by creating an Azure function and calling the Azure function from the Azure Logic Apps? Absolutely possible. But calling an Azure function means that for your workflows, you need to go on Azure and call an external system, an external service, the Azure function, and this takes time. All this runs in the Azure function, in the Azure Logic Apps runtime, the Azure Logic Apps app, and is extremely, extremely faster. So when you want to create high performance workflows, now you have these two very powerful features. One is the stateless workflows. So workflow that runs entirely in memory, no storage persistency. And these are extremely fastest, very useful, for example, for reading data. Limitation is 5 minutes, timeout is 5 minutes. So you need to be sure that your workflow can be completed into 5 minutes. If you are sure about that, absolutely recommended to, especially in a long workflows, create a part of that as a stateless workflows and use them. The second, if you want the maximum performance, especially in my recommendation, especially when you have a lot of loops, when you have complex processing, create a function to do that processing and keep your processing function logic inside this action. And then you can use this action across your workflows, but this becomes extremely, extremely fastest compared to looping. So in these workflows, I don't have looping. And if a workflow don't have looping, it's fast. So in Logic Apps, generally speaking, try to avoid the looping as much as possible, because looping takes time. And why it takes time? Because there's storage under the hood. So that's the reason. So I hope with this explanation to have explained these new features, why these new features are, in my opinion, extremely powerful and extremely powerful, especially for high throughput and high performance workflows. With this example, I finish my presentation. I invite you to explore these new features. These are actually how you can use when you test them. I'm available for question if you want, and feel free to reach me, as said before, on one of these channels when you want, for every type of other question that you can have.
Great. Thank you again, Stefano. We have two questions. Let me share on the screen.
.NET Action available in Power Automate? No, absolutely no. At the moment, no. Are not available in Power Automate.
Yeah, the next question.
Azure Logic Apps with function limitation, for example, is there a limit for execution? Yes. No, at the moment, there are no function limitation. The only limitation is required to the Azure Function Runtime that you can use. So the code that you can write inside the function defined into the Logic Apps must be written in one of the platforms supported by the Azure Function Runtime. So this at the moment means .NET 8 recommended, or also .NET Framework is supported, but .NET Framework support will become to end. So the only limitation is that there's no time limit limitation. So time limit limitation is the same as Logic Apps. The size of the file to be transferred, no built-in limitation. Obviously, usually this should be a code that performs a particular process. So not recommended to have a complex DLL or something like that inside that. Restriction on libraries, you can use any library you have on available on NuGet today. So built-in .NET libraries are available out of the box. Otherwise, you need to reference NuGet libraries in your piece of .NET code. When you reference this NuGet library, this is referenced in your code inside the Logic Apps, and the DLL of the library is deployed together with your Logic Apps. So no limitation on that. The only limitation, not limitation, the only possible counterside of that is that your storage increases, because if I reference a DLL that is, I don't know, 3 megabytes of size, these 3 megabytes are increase my Azure Logic Apps storage, but no other. When you have these Logic Apps, this code defined inside your Logic Apps, the last part of the question is, the answer is yes. You can reuse this across your workflows. So you can reuse this in your different workflow defined inside this your Azure Logic App instance. So absolutely modular and absolutely powerful.
Yeah, great. Stefano, one request about the share your code in the GitHub. It's possible, please share.
Yes, I can share the code on GitHub, absolutely. Yes.
Great.
I will create a repo and I will share the code.
Nice. I think there is no question. We can, if you agree, we can select Mojtaba as a winner for Microsoft Exam Voucher, because there is no more question about that. Mojtaba, please send message to me in the Microsoft Teams or LinkedIn for voucher. And yeah, thank you again, Stefano.
Thank you, and enjoy the rest of the event. And thank you very much for being here today.
Yeah, thank you. Thank you, guys.
Bye.